The last thing that we're going to look at in this section is actually something we've already done before, which is finding the domain of a function that has a root in it. Could be an even root or it could be an odd root. Remember from the past is that if we have an even root, that what we are worried about is that whatever's inside the even root, it can't be negative. We just were talking about that. Whatever's inside the root needs to be greater than or equal to 0, meaning not negative. That'll make sure it's positive or at the smallest 0. Now, if on the other hand, we have an odd root, we don't really care what's inside of the root. The domain will always be negative infinity to infinity. So this is going to break down to an issue of whether or not we have an even root or an odd root as to how do we find the domain. Well, in the first one, if we look at problem A, we have the square root of x minus 3. So what kind of root do we have? We have an even root. When we're worried about an even root, we need to make sure that the inside of the root needs to be greater than or equal to 0. Well, the inside of this even root is an x minus 3. So we want to make sure that that x minus 3 is greater than or equal to 0, meaning we don't get negatives. Well, this is why we covered solving inequalities a long time ago. How do you solve this inequality? Well, you'll add 3 to both sides, and we get that x is greater than or equal to 3. Remember, we have to put our domain in interval notation as always, which means brackets, parentheses, infinities, that sort of thing. Well, so let's draw this graph. Well, x is greater than or equal to 3 means it's going to point to the right, starting at 3 with a bracket because of the equal to. So my official domain will be that graph written out in interval notation. Well, notice that that graph started at 3 with a bracket and continued along forever with an arrow, which means towards infinity. And we always use a parentheses with infinity, so that's our formal domain. 3 with a bracket, comma, infinity with a parentheses. Let's look at another problem. Let's look at B. Again, with B, we again have an even root. So again, because we have an even root, we have a square root. We're worried about whatever's inside again needs to be greater than or equal to 0. Well, what's inside of this root is just an x. So only the x needs to be greater than or equal to 0. Well, there's nothing to actually solve there. It's already solved. So I can go ahead and draw my graph. We have a greater than, which means it would point to the right. The equal to means we've got a bracket starting at our 0. So I can write out my domain using my picture. Well, according to my picture, my domain is going to start at 0 with a bracket and will continue on forever because of the arrow to infinity with a parentheses. So that's my formal domain for that one. Let's keep going. Let's look at problem C. Notice C is a little bit different. Why? Because the type of root is a 3, so the root is an odd root. Well, if it's an odd root, I shouldn't be putting any thought into this. The domain here will always be negative infinity to infinity for odd roots because you can plug in negatives or positives. It will not matter. So looking at D, again, what kind of root do I have? I have a 3, which means I have, again, an odd root. I should be putting no thought into this because it's odd. I can plug negatives or positives into odd roots, so my domain is going to be, again, What? Negative infinity to infinity. I can plug in anything, positives or negatives. Let's look at problem E. Okay, with E, we're back to looking at, let's see, the square root of 3 minus x. So we're back to what kind of root? An even root. So we're back to being worried that whatever's inside of the root needs to be greater than or equal to 0. Well, what's inside of this root? Well, what's inside of this root is a 3 minus x, and that needs to be greater than or equal to 0. Well, how do you solve this? We're going to subtract 3 from both sides, which, be careful, gives me that negative x is greater than or equal to negative 3. Well, then we can divide both sides by a negative 1. Be careful, that's going to flip the direction of our inequality. So it will become x is now less than or equal to. Well, negative 3 divided by negative 1 is a positive 3. So notice our inequality flipped directions. Before it was a greater than, now it's a less than. It's still an equal to, though, so it'll still be a bracket here at 3. It's just pointing towards negative infinity now, not positive infinity. So when I write out my domain now, it will be actually starting out with the negative infinity side, and we'll end at positive 3 with a bracket. One last one here. Notice on this last one on F, we've got the fifth root of x minus 100. Once I see the fifth root, I know I have an odd root, which again means I don't care what's plugged in, positives, negatives, it won't matter. So my domain is going to be negative infinity to positive infinity.